Imagine a frozen relic older than Earth itself, forged in the fiery cradle of a star long dead, now hurtling through the void at 68 kilometers per second, a ghost from the Milky Way's ancient past. On July 1st, 2025, the Comet 3I Atlas pierced the silence of our solar system, its icy heart glowing with secrets locked for 4.6 billion years.
This is no ordinary visitor. It is a time capsule from the galaxy's thick disk, carrying the chemistry of alien worlds, whispering of cosmic violence and creation. As it races toward its December 19 rendezvous with Earth at 1.8 AU, humanity stands on the brink of revelation. Will its outgassing unveil the universal recipe for life? Or will its dust veil mysteries forever beyond our grasp?
The interstellar Comet 3I/Atlas, a cosmic messenger from the Milky Way's ancient disk. In the boundless theater of the cosmos, where stellar lifetimes span eons, rare interstellar objects, ISOs, drift across solar system frontiers, preserving chemical fossils from alien birthplaces. On July 1st, 2025, the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS, telescope in Rio Hurtado, Chile, detected one such traveler, Comet 3I/Atlas, as the third confirmed ISO, following 1I/ʻOumuamua, 2017, and 2I/Borisov, 2019. It streaks through our system at over 58 kilometers per second on a hyperbolic orbit, unbound to the sun and originating beyond its influence. Unlike the inert ʻOumuamua or the modestly active Borisov, 3I/Atlas displays vigorous cometary behavior. A glowing coma, a dust tail, and exotic outgassing that began at $4 Its perihelion on October 30th, 2025, at $1.36 places it just inside Mars' orbit, while its closest Earth approach occurs on December 19th, 2025, at $1.80, approximately 270 million kilometers. A safe but scientifically rich distance. This essay analyzes its discovery, physical traits, and significance, weaving in direct comparisons with predecessors and forecasting observable phenomena during its Earth flyby.
Discovery and trajectory. A high-speed hyperbolic arc Atlas first imaged 3I Atlas on July 1st, 2025, with pre-discovery frames extending to June 14th. Follow-up from the Canada-France-Hawaii telescope and Chile's Deep Random Survey confirmed cometary activity within 24 hours, a faint 3 arcsecond coma and tail. The object's inbound velocity of 58 km per second, far exceeding the local solar escape speed of -42 km/s, immediately flagged it as interstellar. Its official designation, 3I Atlas, reflects both its sequence among confirmed ISOs and its discovery instrument. The comet follows a steeply hyperbolic orbit with an eccentricity of -6.1, inclined at 5 degrees to the ecliptic but retrograde, 175 degrees tilt. Key milestones include October 3rd, 2025, closest approach to Mars at 19 cents, 28 million kilometers. October 30th, 2025, perihelion at $1.36, 203 million kilometers, from the Sun, reaching peak speed of 68 kilometers per second December 19th, 2025. Closest Earth approach at $1.80, 270 million kilometers. Post-2026, permanent ejection from the solar system.
This trajectory, nearly coplanar with the ecliptic, maximizes observational access. Ground-based giants like the Very Large Telescope, VLT, and space assets including Hubble, JWST, and Mars-orbiting probes have already captured multi-wavelength data. On October 21st, during solar conjunction, NOAA's GOES-19 satellite imaged the coma from the Sun's perspective, while ESA's Mars Express and ExoMars Trace Gas Orbiter observed it from just 30 million kilometers away using the CASIS camera. Physical characteristics: size, activity, and exotic emissions. Hubble's July 21st images, taken at 277 million miles, revealed a teardrop-shaped dust envelope around a nucleus estimated at 440 meters to 5.6 kilometers in diameter, likely under 1 kilometer. Dust grains range from micron-sized, ejected at 22 meters per second to 100 micron, 2 meters per second, imparting a reddish hue from complex organics, tholins, similar to D-type asteroids. Outgassing began anomalously early. VLT ultraviolet spectra, July 4th to August 21st, detected atomic nickel, NiI, and cyanide CN, the latter a first for ISOs. NASA's Swift Observatory tentatively identified water vapor and OH on July 31st to August 1st, while JWST confirmed CO2, H2O, CO, and carbonyl sulfide, OCS. Notably, nickel vapor appeared at $4 where temperatures, 100 K, should prevent sublimation, suggesting either cosmic ray-induced sublimation or trapped metallic pockets. The CO2 to H2O ratio is inverted compared to solar system comets, while CO2-H2O 1.4 mirrors Borisov. These traits indicate a pristine, radiation-hardened relic aged 3 to 11 billion years, with kinematic models favoring 4.6 billion years from the Milky Way's metal-poor thick disk.
Comparative analysis, 3I Atlas versus predecessors. To contextualize 3I Atlas, direct comparisons with 1I ʻOumuamua and 2I Borisov reveal both continuity and divergence. 1I ʻOumuamua, 2017, an inactive, cigar-shaped asteroid, tilde 100-200 m, with inbound velocity 26 km per second, eccentricity 1.2, and non-gravitational acceleration but no coma. Originating from the galaxy's thin disk, tilde 1 GYR old, it sparked, later debunked, artificial origin theories. 2I Borisov, 2019, an active comet, less than 1 kilometer, velocity 32 kilometers per second, eccentricity 3.4 to 3.6, with CN and CO₂-rich outgassing, COHO tilde 10 times solar comets. Also from the thin disk, tilde 1.7 GYR. 3I Atlas, 2025, larger, faster, 58 kilometers per second, eccentricity tilde 6.1, with coma, tail, and emissions including Ni, CN, CO, HO, OCS. Origin, thick disk, tilde 4.6 GYR. Thus, 3I Atlas is older, faster, and more eccentric, sampling an earlier galactic epoch than its predecessors. Scientific significance, galactic archaeology and chemical universality. As a thick disk relic, 3I Atlas offers a snapshot of early Milky Way chemistry. Its low metallicity ices constrain volatile formation in metal-poor environments, while OH and water affirm HOS cosmic abundance, vital for habitability. Nickel vapor at $4 suggests cosmic ray processing over billions of years, creating a radiation mantle that bursts upon solar heating. The high CO-HO ratio may reflect formation in a warm, CO₂-rich disk, distinct from solar system norms. Dynamically, its high velocity implies frequent stellar ejections, supporting predictions of 1 ISO per year within Jupiter's orbit. Future missions like ESA's Comet Interceptor, launched 2029, could rendezvous with similar objects for in-situ sampling.
Predictions for Earth approach. December 19th, 2025. $1.80. Though $1.80 is over 7 times the Earth-Moon distance, 3I/Atlas will still deliver rich science and subtle sky phenomena. Brightness and visibility. Peak magnitude, 1213, visible in 8-10-inch amateur telescopes under dark skies. Location, morning sky in Virgo, then Leo by late December. Coma may span 5 to 10 arc minutes, with a dust tail up to 1 degree, twice the moon's width, in long exposure images. Outgassing surge. Post-perihelion heating will drive maximum sublimation, boosting CO, CO2, and H2O production. Nickel and CN emissions may peak, detectable via ground-based spectroscopy. Possible fragmentation. If the nucleus is loosely bound, solar tides could trigger outbursts, producing transient anti-tail features, dust lagging behind. Dust and meteoroid stream. At 68 kilometers per second, ejected particles form a sparse meteoroid stream. No Earth impact risk. The stream trails far behind, but radar systems, e.g., Goldstone, may detect micron-sized grains. Long-term, particles could seed the zodiacal cloud, contributing 0.001% to interplanetary dust. Multi-wavelength observations, JWST, infrared mapping of organic molecules. ALMA millimeter wave detection of rare isotopologues, e.g. D/H ratio. Amateur contribution, photometry and spectroscopy to monitor activity bursts. Cultural and educational impact. Live streams from observatories, e.g. ESO, NASA, will reach millions. Schools may track it with small telescopes, echoing Comet Neowise 2020.
Conclusion: a fleeting window into deep time. As 3I Atlas dims below magnitude 15 by January 2026, vanishing into the outer dark, it leaves an indelible scientific legacy. From its thick disk antiquity to its anomalous nickel vapor, it challenges models of cometary evolution and volatile inheritance. Its safe passage at $1.80 on December 19, 2025, will yield a final burst of data, spectra, images, and dust dynamics before it returns to interstellar space, never to return. In studying this ancient wanderer, we do not merely observe a comet, we read a 4.6 billion-year-old letter from a distant stellar cradle. Its chemistry suggests that the building blocks of planets and perhaps life are not unique to our Sun. As future surveys like the Vera C. Rubin Observatory come online, detecting dozens of ISOs per year, 3I Atlas stands as a pivotal third chapter, proving that the galaxy's comets are universal messengers, carrying the seeds of worlds across the void.